After you cross the troll's bridge and you save the prince or princess, you return them back to their father, the king. And he's so excited that you returned their son or daughter to him that he wants to throw a brunch in your honor. But he has a little bit of a conundrum in throwing the brunch. He wants to figure out how many cupcakes should he order. He doesn't want to waste any, but he wants to make sure that everyone has enough to eat. And you say, well, what's the problem here? And he says, well, I know adults eat a different number of cupcakes than children eat. And I know that in my kingdom, an adult will always eat the same amount, and a child will always eat the same amount. And so you say, King, well, what information can you give me? I might be able to help you out a little bit. You're feeling very confident after this troll situation. And he says, well, I know at the last party we had 500 adults, and we had 200 children. 200 children. And combined, they ate 2,900 cupcakes. 2,900 cupcakes. And you say, okay, that's interesting, but I think I'll need a little bit more information. Have you thrown parties before that? And the king says, of course I have. I like to throw parties. Well, what happened at the party before that? And he says, well, there we also had 500 adults. 500 adults. And we had 300 children. 300 children. And you say, well, how many cupcakes were eaten at that party? He says, well, we know it was 3,100 cupcakes. And so you get a tingling feeling that a little bit of algebra might apply over here. And you say, well, let me see. What do we need to figure out? We need to figure out the number of cupcakes on average that an adult will eat. So number of cupcakes, but for an adult. And we also need to figure out the number of cupcakes for a child. So these are the two things. These are the two things that we need to figure out, because then we can know how many adults and children are coming to the next brunch that are being held in your honor and get the exact right number of cupcakes. So those are the things you're trying to figure out, and we don't know what those things are. Let's define some variables that represent those things. So let's do A for adults. Let's let A equal the number of cupcakes that on average each adult eats. And let's do C for children. So C is the number of cupcakes for a child on average. So given that information, let's see how we can represent what the king has told us algebraically. So let's think about this orange information first. How could we represent this algebraically? Well, let's think about how many cupcakes the adults ate at that party. You had 500 adults, and on average, each of them ate exactly A cupcakes. So the total number of cupcakes that the adults ate were 500 times A. How many did the children eat? Well, same logic. You had 200 children, and they each ate C cupcakes. So 200 times C is the total number of cupcakes that the children ate. Well, how much did they eat in total? Well, it's the total number that the adults ate plus the total number that the children ate, which is 2,900 cupcakes. 2,900. So let's do that. Apply that same logic to the blue party right over here, this blue information. How can we represent this algebraically? Well, once again, how many total cupcakes did the adults eat? Well, you had 500 adults, and they each ate A cupcakes, which is an unknown right now. And then what about the children? Where you had 300 children, and they each ate C cupcakes. And so if you add up all the cupcakes that the adults ate plus all the cupcakes that the children ate, you get to 3,100 cupcakes. So this is starting to look interesting. I have two equations. I have a system of two equations with two unknowns. And you know from your experience with the troll that you should be able to solve this. You could solve it graphically like you did in the past. But now you feel that there could be another tool in your toolkit, which is really just an application of the algebra that you already know. So think a little bit about how you might do this. So let's rewrite this first equation right over here. So we have 500A plus 200C is equal to 2,900 cupcakes. Now, it would be good if we could get rid of this 500A somehow. Well, you might say, well, let me just subtract 500A. So you might say, well, I just want to subtract 500A. But if you subtracted 500A from the left-hand side, you'd also have to subtract 500A from the right-hand side. And so the A wouldn't just disappear, it would just end up on the right-hand side. And you'd still have one equation with two unknowns, which isn't too helpful. But you see something interesting. You're like, well, this is a 500A here. What if I subtracted a 500A and this 300C? So if I subtracted the 500A and the 300C from the left-hand side. And you're like, well, why is that useful? You're going to have to do the same thing on the right-hand side, and then you're going to have an A and a C on the right hand. And you just say, hold on 1 second here. Hold on, I guess you're talking to yourself. Hold on 1 second. I'm subtracting the left-hand side of this equation, but this left-hand side is the exact same thing as this right-hand side. So here I could subtract 500A and 300C, and I could do 500A and subtract 300C over here. But we know that subtracting 500A and 300C, that's the exact same thing as subtracting 3100. 500, let me make it clear. This is 500A minus 300C is the exact same thing as subtracting 500A plus 300C. And we know that 500A plus 300C is exactly 3100. This is 3100. This is what the second information gave us. So instead of subtracting 500A minus 300C, we can just subtract 3100. So let me do that. This is exciting. So let me clear that out. So let's clear that out. And so here, instead of doing this, I can subtract the exact same value, which we know is 3100. Subtract 3100. So look at it this way. It looks like we're subtracting this bottom equation from the top equation, but we're really just subtracting the same thing from both sides. This is just very basic algebra here. But if we do that, let's see what happens. So on the left-hand side, 500A minus 500A, those cancel out. 200C minus 300C, that gives us negative 100C. And on the right-hand side, 2900 minus 3100 is negative 200. Well, now we have one equation with one unknown, and we know how to solve this. We can divide both sides by negative 100. Divide both sides by negative 100. These cancel out. And then over here, you end up with a positive 2. So C is equal to positive 2. So we've solved one of the unknowns. Each child, on average, drinks 2 cups. So C is equal to 2. So how can we figure out what A is? Well, now we can take this information and go back into either one of these and figure out what A has to be. So let's go back into the orange one right over here and figure out what A has to be. So we had 500A plus 200C, but we know what C is. C is 2. So 200 times 2 is equal to 2900. Is equal to 2900. And now we just have to solve for A, one equation with one unknown. So we have 500A, 200 times 2 is 400, plus 400 is equal to 2900. We can subtract 400 from both sides of this equation. Let me do that. Subtracting 400. And we are left with, this cancels out. And on the left-hand side, we have 500A. This is very exciting. We're in the home stretch. On the right-hand side, you have 25, 2500. 500A equals 2500. We can divide both sides by 500. And we are left with 2500 divided by 500 is just 5. So you have A is equal to 5, and you're done. You have solved the king's conundrum. Each child on average drinks 2 cups of water, sorry, not cups of water. I don't know where I got that from. Each child eats 2 cupcakes, and each adult will eat 5 cupcakes. A is equal to 5. And so based on how many adults and children are coming to the brunch in your honor, you now know exactly the number of cupcakes that the king needs to order.